Before there were oceans, before there were continents, and before there was even a sky blue enough to welcome a sunrise, Earth was only a possibility. A future world hidden inside chaos. To understand the birth of Earth, we have to go back not millions, but billions of years, to a time before our planet existed, when the solar system itself was being born from the wreckage of older stars. Around 4.6 billion years ago, in a quiet region of the Milky Way, a vast cloud of gas and dust began to collapse under its own gravity. Yet this was not ordinary dust. It was ancient material, forged in dead stars, enriched by supernovas, and seeded with the heavy elements that would one day become iron in Earth's core, silicon in its rocks, oxygen in its air, and calcium in your bones. As gravity tightened its grip, the cloud spun faster and flattened into a glowing disk. And at the center, pressure and temperature rose until a star ignited. The sun was born. But the sun was not alone. Around it, within that swirling protoplanetary disk, countless grains of dust began to collide, sticking together gently at first to form clumps that grew into pebbles, then boulders, and then mountain-sized bodies. Over time, gravity turned them into something larger still, planetesimals, the first building blocks of worlds. But this was not a peaceful process. The early solar system was violent beyond imagination. Objects slammed into one another at enormous speeds. Some shattered, some melted, some merged. And every collision reshaped the architecture of the newborn system. Somewhere in that storm, in the inner solar system, where temperatures were too high for gases and ices to remain stable, a young, rocky world began to assemble. That world was Earth. But this early Earth was nothing like the planet we know today. It had no forests, no oceans, no continents, and no life. It was merely a growing sphere of rock, constantly bombarded by debris and heated from all directions by relentless impacts, radioactive decay, and the crushing force of its own gravity. As it grew, it became an inferno. Its surface likely melted into a global ocean of magma, glowing red and orange under a choking atmosphere of steam, carbon dioxide, sulfur gases, and volcanic ash. There were no calm seas, no breathable air, only fire, molten rock, and the endless rain of cosmic violence. Yet in that hellish beginning, something essential was happening. Earth was differentiating. When the young planet was hot enough to partially or completely melt, its materials began to separate by density. Heavy elements like iron and nickel sank toward the center, while lighter silicate minerals rose upward. In a surprisingly short cosmic moment, Earth developed a layered structure, a metallic core, a rocky mantle, and a primitive crust. This was one of the most important transformations in our planet's history, because deep beneath the surface, the sinking of molten iron created Earth's core. And eventually, that core would help generate the magnetic field that still shields our world today. Invisible, but vital, it would become one of the great protectors of life long before life itself existed. But the young Earth still had one more cataclysm to endure. A collision so enormous that it would remake the planet forever. Scientists believe that not long after Earth formed, a Mars-sized protoplanet, often called Theia, crossed paths with the young Earth in what became one of the most consequential impacts in solar system history. Theia struck Earth with unimaginable force, releasing energy beyond anything human civilization has ever experienced. Vast portions of both worlds were vaporized or blasted into orbit. Earth's surface was remelted. The sky would have glowed with incandescent debris, and for a time, our planet may have been surrounded by a ring of molten rock and vapor, a temporary halo born from destruction. And from that debris, something extraordinary emerged: the Moon. Over time, material orbiting Earth clumped together and formed our natural satellite. It began much closer than it is today, looming enormous in the sky, with tidal forces far stronger and a presence much more dramatic. This was no minor detail in Earth's story. The Moon helped stabilize Earth's tilt, reducing chaotic swings in climate over long timescales. It drove powerful tides and shaped the rhythm of the planet. In many ways, the birth of the Moon was also the birth of a more stable Earth, a world with a better chance of becoming habitable. But stability did not come quickly. For tens to hundreds of millions of years, Earth remained a hostile place. The surface was still intensely hot. Volcanoes erupted on a planetary scale. Asteroids and comets continued to strike. The young crust formed, broke apart, and reformed in cycles of destruction. And yet, slowly, the planet began to cool. As temperatures dropped, water vapor in the atmosphere condensed, and rain began to fall. Not for a day, not for a season, but perhaps for thousands or even millions of years. Rain fell onto hot rock, filled low basins, hissed into steam, and fell again, until eventually the first oceans gathered on Earth's surface. This was one of the great turning points in planetary history, because water changes everything. It reshapes rock, it stores heat, it cycles carbon, it creates chemistry rich with possibility. A world with liquid water is no longer just a ball of stone. It becomes dynamic, complex, and full of potential. But where did all that water come from? Part of it may have been locked inside the minerals that built Earth from the beginning, released later through volcanic outgassing. And part may have arrived from water-rich asteroids crashing into the young planet. The answer is likely a combination of both. A story written in stone, isotope ratios, and ancient planetary chemistry. But either way, by more than 4 billion years ago, Earth may already have had liquid water on its surface. That alone is astonishing, especially when you remember how this story began: in fire, collision, and molten chaos. And yet now, somehow, a world of oceans was emerging. Above those early seas, the atmosphere was still alien. There was almost no free oxygen. The air was thick with carbon dioxide, nitrogen, water vapor, and traces of other volcanic gases. The sky may have looked hazy, orange, or dim beneath clouds of steam and aerosols. And sunlight filtering through that ancient air would have illuminated a planet both familiar and utterly strange. Beneath the surface, Earth was also becoming geologically alive. The mantle convected. The crust shifted. Early forms of tectonic activity may have begun, though scientists still debate exactly when modern plate tectonics started. But what is clear is that Earth did not freeze into geological silence. It remained active, recycling heat from within and continuously reshaping its surface. That activity may have been one of Earth's greatest gifts, because a geologically active planet can regulate itself over time. Volcanoes release gases. Weathering removes carbon dioxide, and the crust and mantle exchange material in cycles that help stabilize the climate over immense spans of time. They keep a planet from becoming permanently frozen like a snowball world, or permanently scorched like a runaway furnace. In other words, Earth was not just forming. It was learning how to remain alive as a planet long before biology arrived. Then came another brutal chapter, the late heavy bombardment, or at least a period of intense impacts in the early solar system. Massive rocks and icy bodies still wandered unstable orbits and smashed into the inner planets. Earth, the Moon, Mars, and Mercury all carry scars from that age. And for Earth, these impacts were both destructive and transformative. Some may have vaporized oceans, locally or globally. Others may have delivered volatile compounds and complex chemistry. Each one was a disaster, but each one was also part of the experiment. It is difficult to overstate how improbable this all seems. A planet must form in the right region around its star, gather the right materials, survive collisions without being destroyed, cool, yet remain active inside, hold water, maintain a protective magnetic field, and endure long enough for chemistry to become biology. Earth did all of this, not because it was destined to, but because, in the vast lottery of cosmic physics, this world happened to become one of the rare places where chaos gave rise to balance. And that balance changed everything. At some point, perhaps as early as 4 billion years ago, or even earlier, chemistry on Earth crossed a threshold. Somewhere in a warm pond, on a mineral surface, near a hydrothermal vent, or in an environment we have not yet imagined, non-living molecules began organizing into systems capable of metabolism, replication, and evolution. Life appeared. We still do not know exactly how, and that mystery remains one of the deepest in science. But by the time life emerged, the planet had already completed an extraordinary transformation. It had gone from stardust to planet, from planet to furnace, from furnace to ocean world, and from ocean world to cradle. And everything that followed, every tree, every mountain, every whale, every cloud, every city, every memory, and every question ever asked by a human mind depended on those violent first steps. The iron in Earth's core was forged in ancient stars. The water in its oceans may have traveled through space for ages before falling here. The moon in our sky was born from planetary catastrophe, and the ground beneath your feet was once molten. This is not just the history of a planet. It is the deep origin of home. When we look at Earth today, It is easy to see it as stable, familiar, and permanent. Blue oceans, white clouds, continents drifting slowly through time. But that calm surface hides a past almost too dramatic to comprehend. Our world began as a cosmic construction site, a place of impact, fire, collapse, and reinvention. And maybe that is what makes Earth so extraordinary. It was not born gentle. It became habitable through survival. In a universe filled with sterile rock, frozen wastelands, toxic skies, and worlds scorched beyond recovery, Earth found a narrow path towards something rare: persistence, complexity, and life. That does not make our planet ordinary. It makes it a triumph of cosmic history, a world assembled from dead stars, shaped by gravity, remade by collision, cooled by time, and transformed into the only place we know, where the universe has awakened and begun to wonder about itself. So the next time you stand on solid ground, watch the moon rise, or hear waves breaking against the shore, remember what you are really witnessing: the aftermath of creation, the long echo of fire and dust, the survival of a planet against impossible odds. This was the birth of Earth. Thank you for watching Cosmic Earth, and we invite you to subscribe to the channel and join us for more journeys through the story of our planet, our universe, and our place within it.